The movie we decided to do our project on was Remember the Titans, a 2000 football movie commonly starring Denzel Washington. It was based in Alexandria, Virginia, and was about a newly integrated, racially divided team in the 1970s. The specific scene we're doing starred Rev, a quarterback, taking a snap from his center. Before the play, the center audibled, letting the rest of the offensive line know that a blitz was coming from the left side of the field. The left tackle during the game purposely missed the block, ignoring the center's audible and taking reference from what the center wanted him to do. This caused the defender to run in a straight line towards the quarterback, blasting into him and sending him to the ground. During the movie, the team physician came onto the field and stated that the quarterback suffered from a wrist fracture and would not be playing anymore that season. The question we're asking is, was enough force generated in the inelastic collision between the football player that was tackling the quarterback and the quarterback back onto the football player to actually fracture a carpal bone in the wrist? It actually takes 500 newtons to fracture a carpal bone in the wrist. We're hypothesizing that the movie was actually correct and that the defender, when hitting the quarterback, actually created that much force and able to break his wrist and take him out of the game. Through careful estimation and use of physics principles, we're going to try to deduct a sound reasoning on if it actually could have happened in real life.
Rev, I swear to God, I audible.
I didn't hear.
All right, fellas, coming through.
Swear to God.
Let's take a look at that, son. Now, they broke a bone in the wrist. He won't be throwing any more this season.
In an inelastic collision, the two masses that are colliding remain in contact with each other throughout the duration and after the collision occurs. This scene is a perfect example of this type of collision. It is shown that the linebacker made a beeline to the quarterback, hit him head on, and they both fell to the ground as a unit, perfectly displaying this concept as an inelastic collision.
Since the velocity and time in this case are subjective, we estimated through careful research and determined the best fit value for the situation with the defender coming into contact with the quarterback. The initial velocity of the defender is 0 meters per second because it's before the ball is snapped. The final velocity is what we estimated to be 8 meters per second. The time we estimated was 1.2 seconds, which represents the time it took from the snap to the hit. In order to figure out the value for acceleration, the values needed are the change in velocity and the time it took before the defender reached the other player.
Force is determined by multiplying mass times acceleration. Since we estimated the terms of initial and final velocity as well as time, we were able to determine a value for the acceleration. So now, for the force calculation, we needed to estimate a value for the weight of the defender as well. An average high school linebacker weighs about 96 kilograms, which is what we use to calculate the amount of force he drove into the quarterback.
To find the acceleration, you need the change in velocity over time. The final velocity is 8 meters per second, minus the initial velocity of 0 meters per second. That value is divided by the time it took for the defender to reach the quarterback, which is 1.2 seconds. The acceleration value we got was 6.66 meters per second squared. Force is equal to mass times acceleration. For force, we use the mass we estimated of 96 kilograms times the acceleration value of 6.66 meters per second squared. For the force value, we got 640 newtons.
In order to break the wrist, there needs to be 500 newtons of force, and the number we came to was 640 newtons, which is more than enough to break that wrist bone. In conclusion, from the force that we have calculated in our equations, the defender did in fact possess enough force for the quarterback's wrist to fracture.